Hi, my name is Tiffany and my unknown is 307, and I came to the conclusion that my unknown is a 1,2-dimethoxybenzene. And how I came to that conclusion is based on my IR and NMR results. I first looked at my IR results, which shows a peak at around 1,600, indicates the presence of aromatic compounds with the C double bond stretched. This is further confirmed by the peak near 3,000 belonging to the benzene ring, which I showed here. And near the 2,950 is the characteristic of CH stretch with the sp3 hybridizations. And whatever past 1,500 is usually ignored in this class except for ether. I saw a peak at around 1,250, which implied the presence of CO stretch of ether. But however, this needs to be further confirmed through NMR results. So I looked at my NMR results. On the left side is the zoom out versions, and on the right side is the zoom in versions of the two peaks that I saw on the NMR. So there is a peak at around 7 ppm, indicates the presence of benzene ring, which confirmed the IR suspicions. That's shown here. It seems that there are two doublets if you zoom in like this, which indicates the hydrogens on the benzene ring might not all be chemically equivalent to each other. And the benzene ring has 6 hydrogens on it, which explains the multiple splitting around the doublets due to the nearby hydrogens. And another factor to look at that can help me in the identifications of the second peak at the 4 ppm is through the integrations values and the basic knowledge that at around that range of ppm indicates the presence of alcohol, ester, or ether. I can quickly cancel out alcohol because there's no fat dip at around 3,600 on my IR, because usually there would be a fat dip here if there is an alcohol. I can also eliminate ester because there's no carbonyl at around 1,700, which is here. And that left me with ether as the only option left. I can look at the integration values to find out the number of hydrogens by dividing the smallest integration values, which as you can see on my NMR, there are 4 values because there are 4 peaks, but then we can ignore the last 2 peaks because they are too small to even determine anything. And it's also the integration values is too small for that, so I used 39.1 as my smallest integration values, and I divided that with the 59 integration values to get the ratio of 1 to 1.5, which then I multiply by 2 to get rid of the decimal point because it's impossible to get a fractions of a hydrogens. And after that, I got the 2 to 3 ratios after multiplied by 2. And however, the possibility of having 2 hydrogens with 4 empty positions for sidechains that have a total of only 3 hydrogens is very low. So for example, when there are 2 hydrogens present and the rest are sidechains, it is the percentage of having 3 sidechains with only 3 hydrogens is low because there has to be other, like for example halogens or any other options that doesn't have a lot of hydrogens, and all of it in total add up should only have 3 hydrogens, which is almost impossible. But there's also no other peaks that indicating other molecules other than hydrogens, carbons, and the presence of oxygens in the ether. I then listed out all the potential options and automatically crossed out the fraction numbers because it just doesn't make sense to have fractions of hydrogens. So I crossed out this, and that, and I also crossed out the 2-to-3 ratio because we talked about this. So the only options left is 4-to-6 and 6-to-9. So I first look at the 6-to-9 ratio, which does not make sense because if there is a benzene ring and there are 6 hydrogens, then there is no other spots for other side chains to take place, and that so it doesn't make sense to have additionally 9 hydrogens on the side chains. So I eliminated that ratio options, and that left me with the 4-to-6 ratio. That makes more sense because the benzene ring has 4 hydrogens. 1, 2, 3, 4. That left me with 2 spots for the side chains that very likely to have 6 hydrogens because 1, 2, 3 and 1, 2, 3. That give me a 6 hydrogens. So 4-to-6 makes the most sense. And I know that there is an ether because we talked about this before in the IR. It shows there is a peak at around 1,250. And also we eliminated other options, alcohol and ester, so that left me with ether. So that's how I came to the conclusion that my structure is ether with hydrogens and ether with hydrogens. And how I came to conclusion that it is an ortho position is because on the benzene ring there is 2 doublets, which indicate an ortho because I mentioned before the hydrogens are not all of the hydrogens are chemically equivalent to each other, because if they are, that means that you can only see there's one single peak going up and it's going to be really tall, but then you see that there's 2 doublets, so that means, so if it's chemically equivalent, so para like this, then all of the hydrogens are next to the ether, so that would make it chemically equivalent to each other, all of it. But then since we see 2 doublets, so that indicates that the hydrogens are not chemically equivalent, and this hydrogens is equivalent to this hydrogens due to it's nearby to the ether, and this one is chemically equivalent to this one because they are not close by to the ether. And the rest of these hydrogens are equivalent to each other because they are close to the oxygens just like one another. And that's how and then they are not on the benzene ring like the HA and HA. And that's how I came to the conclusions that my final structure is 1,2-dimethoxybenzene. And thank you.